Welcome to everybody who's coming to join us for our Globe Annual Meeting Workshop. I'm going to give people a little bit more time to walk down the virtual hall to join us. We have a few people in the room so far, but we're expecting about 30 people or so. So thank you all for coming. And if you, while you're waiting, if you'd like to introduce yourself into the chat, that would be wonderful. We are always interested to find out where people are joining us from, who you are, so that we can actually create a nice learning community here together. So thanks for joining us today, and get comfortable. Wonderful to see everybody starting to join our room and introduce yourself to each other. I know that's one of those challenging pieces of all of this. And I'm really glad that you all could join us today. And I'm looking forward to answering any questions that you guys might have. We're here to talk about one of my favorite subjects, which is land cover and trees and tree height. So we're hoping to actually do a little bit of outside or data collection today. So while you're waiting, make sure that you have downloaded the Globe Observer mobile app from your app store to your mobile device. That will make the data collection piece that we'll be doing in the middle of our workshop here today more fruitful for you. But be aware that whenever you're doing a training or working with people, usually the setup stage is the first thing that we have to do. Make sure everybody has a mobile device. They've downloaded the Globe Observer mobile app. And then third is registering. You need to either use your Globe user ID to log in, or you need to create one. And that takes a little bit of time, and you might have to access your email with that. So if you just take a moment here and take the time while we're waiting for others to gather in, everybody who RSVP'd, that'll set you up nicely for our workshop today.
And Peter, I'm back on.
Great. I'm glad to hear that, Lynn.
Me too. I had to restart my computer.
Isn't that always the case, you know, when you're doing these presentations, that you will almost inevitably have a computer problem? So if that happens to any of us, let us know. If you can't hear us for some reason, if our internet gets choppy, let us know in the chat. We'll do our best to accommodate and be aware of those issues as they might happen. Okay, so let's get going since we don't have a lot of time today. Again, I want to welcome everybody to our intermediate training here today at this 2020 Globe Annual Meeting. Today we're going to be talking about land cover and tree height. And today your training team is me, Peter Nelson. I am a Globe partner at Oregon State University in the College of Earth, Ocean, and Atmospheric Sciences. I'm also the land cover science lead for the Globe Observer mobile app and the Globe Observer project. So I come at this from many different lenses, and I'm really excited to present to you today and to get you excited about collecting and doing science with land cover and trees. But I'd like to have my team, the other protocol training team, introduce themselves today.
I'm Lynn Hare. I've been with the Globe program since 1995, was one of the pair of the first Globe training workshop that we did ever. And I'm currently the vice chair of the Globe Education Working Group. And Arkansas is very cool today, which is unusual for July.
Hello, everyone. I'm Aminulai Modupe from Nigeria, Globe Coordinator. I'm a trainer in Nigeria, and I'm happy to be here today. Thank you very much. So enjoy your stay with us.
Thank you very much. Like I said, I'm excited to have this training team working and helping us to support a really important protocol or set of protocols here related to biosphere. So, Lynn, tell us a little bit about what we're doing and how we're trying to make sense of Earth.
The world would be an extremely boring place if this was the only view we had of it. No information, no color, no atmosphere, biosphere, no hydrosphere or geosphere, no detail at all. If we add in our globe community, the world begins to open up. Climate starts showing, soils, land covers, water systems all emerge to tell us information about where we all live. The Earth on and the climate in which we live impacts everything in our corner of the world. Do we live at sea level, mid elevations, or high in mountain ranges? Is our climate humid, arid, or somewhere in between? The stars on this map show that Peter from the state of Oregon in northwestern United States, Lynn from the state of Arkansas in the mid-continent United States, and Amanule from the country of Nigeria all live in very different parts of the world. With the Köppen-Geiger climate classification map, we can see at a very large scale that we appear to have some similarities, but also some major differences. A part of Oregon shares a temperate climate zone with Arkansas. A second part of Oregon also shares a dry climate zone with Nigeria. So how are our areas similar and how are they different? The interplay between the main Earth systems, atmosphere, biosphere, hydrosphere, and geosphere can tell the story, but what do they really tell? The land, geosphere, and climate, which involves atmosphere and hydrosphere, set the stage for land cover, plants, and animals, the biosphere. The interaction between these four spheres, all working together and impacted by the sun, is called Earth system science. And throughout the Earth, it makes major differences in each of our personal worlds. In Arkansas, I live in the northwest corner within the Ozarks, an oak hickory forested area full of high hills, river systems, and wooded areas. The other major divisions of Arkansas vary from flat farmlands to rolling hills and coastal plains. All have 4 fairly evenly spaced seasons, and the progress that Northwest Arkansas is experiencing right now. We have huge population influx, and it's really impacting our natural beauty. Arkansas is known as the natural state, and we want to keep it that way while also welcoming others to be a part of it. Amanulai?
Hello, everyone. I'm Aminulai from Nigeria. And I want to tell you a little bit about Nigerian land cover. Nigeria is currently undergoing rapid, wide range changes in its land use. In Nigeria, these changes are largely due to human activities rather than climate change. The cultivation and the rapid infrastructure development have all resulted in substantial loss in forest and grassland. In the north part of Nigeria, there is a transition from savanna to agriculture due to emerging farmland, while in the south part of the country, recurrent oil spills caused by accidents due to poor maintenance and sabotage have greatly affected the ecosystem. Wildlife in the forests are now under threat with environmental pollution and issues. From recent study from 1984 to 2020 shows that forest has reduced from 66% to 6%. Build-ups has also increased from 4 to 40%. Grassland has also increased from 4 to 11%. Water bodies has reduced from 4 to 2%. And bare land has increases from 20 to 38%. And all this has caused by the following: environmental issues like increases in population, rapid growth in infrastructure and urbanization, and then we also have the problem of weak environmental policy in our country. All these are what we have in our land cover and land use in Nigeria. Thank you, everyone, and enjoy your stay with us.
Thank you. And I think it's really interesting to compare that to where I'm joining you all from out here in the northwestern part of the United States in the state of Oregon. And here we have landscapes of glaciers with volcanoes, a lot of bare land that is in some cases now getting forested. And so we have really old forests in Oregon, trees that are 500 to 1,000 years old. But we also have urban areas that have buildings, but also have a lot of trees. Here in Portland, we're known as a tree city. So when I look at our landscapes, I think of questions like the urban heat island effect. That when we're measuring urban heat island, we're actually measuring land cover, right? When we're measuring the temperature of water bodies, we're measuring water. When we are doing a lot of different aspects of thinking about land cover, it really is the basis for how we can start comparing different places together like this. And for me, a picture really tells the differences here. So I hope that you can start to see how talking about land cover and different types of trees can bring us together as a community. And we might be able to see some common trends, like the increase in barren areas or the increase in urban areas. And I think also this desire to keep natural areas natural is something that is common between where I live and where Lynn lives and where Amanulai lives. I think this is one of the great challenges of the Globe community is how do we help people understand these different environments, not only locally, but also globally?
So talking about where we live is fine, but sharing our information with others through the globe system is most important. So here are the three of us on the globe data visualization system. When we collect and enter data using globe protocols, our individual stories begin to emerge. That's why it's so important to collect, enter, and analyze data. To use the globe visualization system for data analysis, it's really easy. 3 major steps get you started. First, select the type of data that you want to look at. Next, select the date or dates you want. And then last, click on the data point on the map to receive table and graph information. If you'll notice on the left, demonstrations and tutorials are just a click away if you need more help. One of the most important bundles of information needed has to do with land cover and trees, and that's what this session is all about.
I find it really powerful when we start looking at not only where we have data that makes it possible to have students and communities use the globe data and the globe visualization system, but it can also help us to see where we don't have any data and where we might need to reach out as a community, or where there might be some really rich opportunities to partner or to add to this rich data set. And when we look at this, how many people who are on this call have a blank spot? There's no data around them. And feel free to speak up or to drop a note into the chat. I'm just kind of curious, when people see this map, do they see themselves on it? Do they see data that they could work with? All right, so Claudia, thank you. Yes, yes, you see yourself on the map, but really nothing to work with in Paraguay. Yes, exactly. And to me, you know, this is one of these places that you know, I'd like to emphasize a little bit. Let's try to densify this map and make sure that we have good examples of land cover for all of our globe countries. You know, because that is so foundational to almost anything else. What protocol are you going to do goes back to what land cover is there. So I like to understand where data is at, and that's my lens. And so I hope that if you don't see any data there, what you collect is going to be even more valuable. And if you do see data on the map, that doesn't mean that we still don't need help. It means that we could actually probably use more data in those locations to be able to do some different type of science. So really, really exciting. And so make sure that you use the globe visualization system to understand where we might need help or information. So just a quick poll. How many people here have done Globe's land cover biometry protocol? And here I'm curious, because there is a distinction between Globe Observer and the Globe land cover measurement. So here I'm curious, how many people have done the measurement, laying out a tape and actually using the tube and doing the ground cover and tree canopy, and have done that full muck measurement? Feel free to raise your hand with this, or drop a say yes in the chat if you have. I'm glad to see at least a few people have. What's interesting about this protocol is that it is one of the oldest protocols that Globe has, yet we have not had as much data coming into it as we need to be able to do science with it. So the amount of, you know, it takes about a good hour or 2 hours to lay down the tape measures and to actually walk that and to do all of that. And if you have time, that is really valuable. However, now with the mobile app, Globe Observer Land Cover, I consider a rapid assessment. if you don't have time to measure out every single thing, then we can make estimates using the Globe Observer land cover tool. And this has us do pictures and do some estimates, and as a complement to making these measurements. And Eric Brown de Colston is on the line here, and him and I have talked a lot about how these two things go together: the rapid assessment together with the measurement. That's actually really, really valuable to pull the two things together. Okay, so we have some experienced people using the land cover biometry protocol. How about the biometry or the biometry tree height protocol? How many people are measuring tree heights? All right, so we have a few people definitely who are measuring tree heights. That's great. I love this. Tree height seems to be one of those things that people gravitate towards. It's it allows you to focus on a single tree or a single land cover element in the landscape. It allows you to make a relationship to that individual tree, and you can start thinking about that tree within its landscape. How far apart is it with its neighbor? How far does a bird or a squirrel or a mosquito have to travel from one tree to another tree? And all of this actually goes back to land cover. How closely or loosely spaced are those trees is one of the first questions that we have of whether that is a tree dominated landscape and therefore you're doing tree height measurements, or are there not enough trees or no trees and therefore you cannot even measure a tree because there are no trees in the landscape, right? You are actually doing a classification when you make this choice of, I'm going to go measure that tree. You have done a land cover classification right there. So I love that we have people who are experienced in doing some of these protocols. If you're not, that's totally fine. That's what we're here to talk about. And so our training today, we're pretty much right on schedule right now, which is great. I like it when that happens. So we've spent a little bit of time of talking about the globe visualization system, where our data goes and where our data has been going for 25 years. Remember, land cover is the site definition. And so it's important before you do any other protocol to describe what is in that location. And importantly, what is in that location today. It may not be the same land cover in 1 year, 1 month, or even the next day. Here in Oregon, we experienced lots of wildfires last year. And so many of our original land cover sites or site definitions, we might have to update or change. And remember, trees are growing, shrubs are growing, rivers change course over 25 years. So even though you might have done land cover, done the measurements, you do want to revisit that and think about the changes that might be happening to the landscape. Okay, so when we're thinking about trees, we're thinking about where they are and how tall they are. When we're thinking about land cover, we're thinking about whether there are trees there or whether there aren't, and what other land cover elements that are there in the landscape. So Globe Observer is, again, our mobile app that allows us to do data entry on the go very quickly in an area where we may need to do just a rapid assessment. Sometimes we have a tape measure with us, sometimes we don't. Globe Observer was really developed to help facilitate an instrumentless experience when you don't have a tape measure with you. And that's one reason why I say Globe Observer land cover is slightly different than the Globe land cover itself, the actual laying out of the measurement tape where you can measure things. So again, slight distinctions. And same thing with the tree height. When you do Globe trees or Globe Observer trees, you are making an estimate of that height. You can use a tape measure and do that, but the whole intention was that you would just be pacing or making an estimate of that height. So you can see there is some differences in the data that's collected through Globe Observer versus using tape measures and using some of the protocols that you can also do. So I want to make that distinction. One of the things that is important is that Globe Observer is maintained. It works on Android or iPhone devices, and importantly, it can work offline. And so you can collect data offline, but you don't have a map. And there's some other little issues there like that can get into data quality. But I just wanted to highlight that the tool allows you to get involved and to collect data wherever you are. And previously, if you had been using the Globe Data Entry app or tool, that is being currently migrated and brought into Globe Observer. So there will only be one mobile app for the Globe program, Globe Observer. So just kind of recognize Atmosphere is always leading the way, as it has at the very beginning. So you'll, if you look at any of those protocols, you'll see what's sort of where we're going with Biosphere and Hydrosphere and Pedosphere. Okay. Nice thing is, training is built into the app. And so when you have your students or your community download the Globe Observer mobile app, you can basically have them do the very first badge inside of there, which is capturing those photos, just doing that badge. And it takes 2 minutes for somebody to walk through that process. But it has to be done before you can unlock and you can start collecting data. So let me see how many people have already downloaded and unlocked their Globe land cover protocol. All right. Got a couple of people? Great. All right. So when you're doing this with the community members, just remember that you download the app and then you have to do the setup time. And so if you've done that ahead of time or send people an email, which we didn't do, but hopefully you have some time to have people download the app ahead of time and to do that registration. But here, so the first thing in this protocol is we capture photos in a particular location. And those photos, as you'll see, are done in a systematic way. Then optionally, you can classify or estimate the land cover that is in each of those different directions. And then ideally, you can compare that to some of the satellite maps of land cover that's out there. That third piece, comparing what you see to the satellite data, is, I'd say, one of our big science objectives here. So, but that's a piece that we don't expect everybody to get to, especially in this initial training. But just recognize, capture, classify, compare. That's what we're trying to do with the mobile app. I am going to hopefully, nope, thought that was going to be the video, but so what I'm going to do is let's take a moment, or I'm sorry. We have the land cover tool, and when you go through, you take photos in 6 different directions. And so you take a picture in the north direction, east direction, south direction, west direction. And then first you start with an up and then a down. And the up and down are very similar to using a tube and doing the measurement for canopy cover. So it can be really useful when you are looking and thinking about canopy cover or even building footprint size. And then, what we'd like you to do is label, if you're looking northward, what do you see in that direction? And it might actually be different than any of the other directions because the landscape is not the same, right? And depending on the level that you're looking at, you might label something as grassland, but there might be, individual land cover elements of grass or an individual tree or maybe some roads in there that are part of that pixel, but are not the dominant part, the dominant land cover. So that's why we're asking you to identify all the different pieces of the land cover elements that you see inside of there and approximate the percentage. So again, this step can actually take a bit of time, but it goes relatively fast in the field. People don't need to do this, and so today, don't feel like you need to do this step for our activity. If you're able to, great, but this is the one that seems to confuse a lot of people. And so depending on your objectives, you might want to just focus on the pictures and then teach a little bit more about the classifications itself. You can always find out with the little I as you're doing this, a little bit more about the definition of them. And so you can put together the subpixel elements that come together to create this pixel that we're trying to map with land cover. Hopefully that's nice and clear. And Eric, thank you for mentioning that. When the developers created this, they did not have a 1%. And so the minimum percentage you can put into here is 10%. This gets into the science that we can do and some of the analysis afterwards, but just kind of recognize that, again, it's a rapid assessment. We don't expect it to be 100% correct or as good as the muck measurement, but it gives us an indication of what's most there and what's least there, kind of a proportional thing like that. Again, we can spend a little bit of time talking about some of those nuances after you get a chance to maybe collect some data today. But again, if the photos are one piece of data, really useful. The labels associated with those are another piece of data, more useful. And then that comparison to the satellite data is even more useful. And I find that if you are looking for trees, well, why not do that land cover and put that tree into context? Or if you are mapping land cover and you recognize that there are trees there, well, add that three-dimension, that Z part, that structural piece to our data set. And so, Globe Observer trees and Globe Observer land cover, I see as connected. If you do one, if you identify trees, put it in context with land cover, and if you are estimating a height of trees, add a land cover in, either at the base or where you do your estimation from. And the whole idea here is that land cover gives us the spatial arrangement. Where are things located? What's green on the landscape? What is blue on the landscape? That spatial arrangement is what land cover does. But you notice in that definition is actually a piece about how tall is vegetation so that it can be labeled as a tree or as a shrub. Globe has a definition, 5 meters. Something has to be 5 meters tall to be considered a tree. And so here, if you recognize that there is a land cover element that is a tree, go ahead and use the protocol, the tree protocol, to actually estimate that height. And that again gives us that structural piece, and trees grow over time. And that's all important when we're trying to measure these things from space. Okay. We have a whole campaign around trees around the globe, and that is to support two really exciting missions that are actually measuring height of vegetation in particular, but also tree height can be deduced or pulled out of that. All of that goes into helping us model and measure carbon on the landscape, for instance, or the effects of changes on our landscape. And so, you know, when you do this, you have to set it up a little bit. You have to know how tall you are. You have to know your average stride length. And so there's a little bit of setup that has to go into this. And so when you do this, it's best to be at a track or a place where you can lay out a tape measure and actually get that pace. Again, it's an estimate, and those numbers affect the trigonometry on the background. But when you do this, there is an option if you are walking around with a tape measure to actually measure the diameter. And again, you know, or the circumference of that tree. Height, circumference are numbers that can be used to estimate carbon or the size of that tree. And so those numbers can be useful down the line. But you notice that this piece is optional because Globe Observer is only using the sensors in a mobile app. And only a very few of them now have LiDAR and have an ability to actually make a measurement. And so this circumference piece is optional with it. And so there's, again, you know, this protocol is written up inside of the app. And so if you have any questions about any of this, feel free to go in and use the little question mark in the bottom, get some answers there, or ask us some questions. That's what we're here to do. Okay, so we all know about biosphere and why this is important. So what I want to do is I want to give you guys a chance to actually go outside and to try to collect some data or to go through those first badges and set up the app right now. So we're going to take about 10 minutes here so that we have a little bit of time for discussion. But if you'd like, take the next 10 minutes till 11:30 my time, 12:30 Mountain Time. Add 10 minutes to where you are or so. Feel free to step away from the computer, go outside, make an observation, try to measure a tree height. And we'll be here, and at 11:30 we'll answer some general questions or have a little bit more of a conversation about how you guys might be using this or might want to use it in the future. Some of those considerational questions. So if you want to take the next 10 minutes and go through the app, go outside, take some data, great. We'd love to see that, and hopefully it can populate on the map pretty quickly since we're all Globe authorized users here. So thanks. Very quick overview about Globe Observer land cover, Globe Observer trees, but you know, we only have an hour, so I'm trying to pack maybe too much in, but this is what we're spending some time talking about today. So feel free to ask any questions in the chat, step away, or you know, unmute and ask a question if you have any. Yeah, Emilio. Yes, the login should be the same on the Globe Viz site as it is for the Globe Globe Observer. And so if you know, you can always double check to make sure that the sign in is the same, but you can always go into, you know, sign in on the Globe website, double check that that's all right, and then go back to the app to just double check. But it should be exactly the same with that. All right, so Inez, yeah, okay, so Land cover indoors. I would think about it in terms of not taking a picture inside exactly where that that mosquito trap is located. You can take pictures of that through the mosquito protocol, you know, the habitat ones. I would say step outside and put. I would take pictures of the buildings that you're in, or that piece of things. And so kind of putting that indoors. What is indoors? Is it a single house? Is it a really tall high rise? What's the vegetation around there, or is there water around there? So yeah, so I think the way I would think about this is, what is the building? What is the context that the building is sitting in? What's the land cover surrounding there? Because in your case, you know, mosquitoes are traveling from one land cover type into that building and that piece of things. So that's, I think, one of the big things to just kind of think about is that scale, and I think that's an important one. And I think, you know, the other piece is we're trying to look down from satellites, and we would never be able to predict what's inside of a building necessarily, but we might be able to predict, based off of the type of buildings where we're finding mosquitoes, maybe there might be something to that we might be able to predict or might be able to use with our satellite data. Okay, so let's see. So Svetlana, thank you for emailing me. You're having a hard time. Roller, could you put the new help desk email for Globe? I know that they
You
changed it,
got it.
and I've had
Yep.
the same problem, Svetlana. So I appreciate that, Roller.
Roller, I'll email you. I've had this problem for a year. I used to be able to get into Globe Observer with no problem, and then I'm reluctant to change my password because it means I also then have to change it on the site, I think, right? So
No.
it's so you're out in the field and
this
you're
done.
logging your password and it doesn't get in, and then you have to wait for the help desk to respond, and it just okay.
Svetlana, I appreciate that lament, because I've had that experience myself out in the field. Something happens, and if you are in offline mode, you are completely locked out of the app at that point, right? So that I've had that big issue. So one of the things that I do as a trainer, when I think about this leading a group out, is to actually have some backup usernames that I just kind of have, you know, maybe my student accounts or something like that, that I can always hand to somebody. You know, that way you just have that backup. It doesn't get associated with their account, but it's at least a little bit of a backup. But I'll say, you know, for most people, they don't have the patience to go through some of these issues like this. So, you know, this can become a barrier, just getting into the app. So I recognize that, and I've tried to build some safeguards, but recognize that this piece, I've spent a good hour at the beginning of trainings just getting people online and getting them into the app before we actually do things. So it is a bit of a hurdle. And then for non-Globe people, they don't necessarily have a good password that they can remember. It's a gibberish kind of one. And so they actually have to get it resent sometimes. And so that process right there can just add to the data collection. So just, you know, these are the technology challenges, right? And then the other thing that I do sometimes is I have a backup devices that I have. So I can always hand one off and let somebody collect it that way without it.
Yeah.
Doris, yeah. So okay, so that's a good one. Yeah, so it's dark where you are, and you can't go outside, and it's not safe to go outside to make those observations, and that's good, and that makes a lot of sense. And so, you know, that's one of these fun challenges of doing a workshop at all hours. It doesn't work out for everybody like that. So I appreciate that, Doris, because that is safety is one of our big considerations here. And so, you know, the other thing is most of our satellite remote sensing is using sunlight reflecting off of the ground. And so we're making some observations at night, but you're right, it is a lot more challenging. And so we tend to, if we get photos that are too dark or taken at night, we have to remove those from our analysis. They're not removed from the database. The Globe database has all kinds of raw data in it, that isn't good for or useful for analysis, and dark pictures are one of those. And to this point, I've seen that when you give students an assignment and you say, we need 10 observations from everybody, sometimes they come back with photos at night because they're just trying to get them done. And so actually having a check on the quality of the data that they're submitting and getting points for, I think it can be really useful as a way of minimizing some of the bad data that can end up in the Globe database. So Doris, thank you for mentioning that time difference piece of things. There is, you know, the black marble and some efforts like that to use the night lights to identify urban centers and different things like that. So there is value in remote sensing at night, but for our purposes, our protocol tends to really focus on those daylight hours and primarily when it's brightest with it. Yeah, thank you, Anna, for mentioning urban areas. Urban areas are problematic and can be a very challenging environment to do Globe in. And so a lot of times our spatial size changes. And so even though the muck land cover measurements are being made at 100 meters pixels, sometimes that's too big for and covers 3 or 4 blocks of a city. And so we found that for certain questions might be too coarse. And so thinking about that urban environment differently sometimes might be necessary. So I'm glad to see that there is that protocol there. One thing that I'll mention about working in those urban areas. So when we're collecting our photos, NASA's concerned about privacy, and the funders of Globe are concerned about privacy. And many countries that Globe is working in and operating in and supporting also are concerned about privacy. So when you submit a picture, if you are a Globe citizen scientist, we have a team that actually will review those photos looking for people's faces or license plates or some of these other identifiable or very text heavy parts of our landscape. And they will reject those photos. And so you will find in the database that there's not a URL, a place to see that photo, but actually rejected as the tag. And so we want to minimize the number of rejected photos that we get. And so when you are in an urban area in particular, doing land cover observations or even tree height observations, you want to minimize those things that will get a photo rejected. That being somebody's face or license plates or some of those additional privacy concerns. And so, you know, sometimes I just will stop and wait for people to pass. Or I will make students turn around and face away from me so that we don't get faces, but we can still get scale or some things like that in there. Now, Globe, if students have Globe accounts or with your Globe account, nobody looks at your pictures. And so whatever pictures students take with their student account will end up in the database. And that can be problematic, and there's an additional burden on filtering some of those things out. So as much as you can, encourage people to not take pictures of people's faces or with people in them, really, or with car license plates in particular. Those are the two things that we're screening for with privacy and get a picture rejected. Okay, so urban areas. They're really valuable, really good. And if you are doing urban heat island campaign, you should be thinking about land cover. When you are measuring a surface, you are measuring a land cover. And so even if you are doing that campaign, still use the Globe Observer land cover tool to take pictures and to record the land cover that you are actually measuring. And that will help when you try to combine it or look at the satellite measurements of surface temperature, or try to understand and do that science project. Land cover is fundamental to Urban Heat Island, fundamental to our Trees Around the Globe campaign, fundamental to a Globe Mission Mosquito. So that's my little pitch on land cover. It's everywhere. So we should be getting a lot of data with land cover. Okay, that's a lot of me talking. Anybody have any questions or want to speak up? We have about 10 minutes or so left here. Looks like we have a good question here from Marella. Trying to send in your observation and you get an error message. I got this as well. We are experiencing issues with our servers. Please try to submit your data again later. Okay, so you get a red exclamation point that shows up when you go to send your data to Globe. Yes, so this was a big bug that caused us to lose data at the beginning 2 years ago, but we fixed. So when you see that red exclamation point, it just means wait 10 minutes or 15 minutes, maybe even an hour, and just try click that observation again and try sending it again. Globe, in theory, it won't get deleted off of your mobile app until the data has made it to the database. And so just keep trying to send in your data. I think I had the experience last night. So with the app update, Globe Observer app update that happened, some of these things, the Amazon servers that Globe is running, sometimes it takes a little bit to say, oh my gosh, we have a lot of people sending data. I need to wake up and do something. Sometimes that happens. So yes, just try again later. But one thing that this reminds me of is, if this is the only thing that you're using to collect data with, there is the potential for losing data. It could happen with your mobile device crashing. It could happen with data getting lost in this transfer. And so one thing, the science protocol that I've developed is to have a field journal of where am I making observations and how many photos did I take, and have some of that so that when it does end up at the Globe visualization system, you can double check it. Again, good science is double checking and having sometimes not just that single measurement of a tree, but sometimes having multiple measurements of a tree. So even though we have an app and we have a computer helping us, still continue those really good science lessons and science methods that we use, journals and double checking our data. So yeah, that was a great question that I just saw came up. And so the error message is also really useful. So pay attention to those. All right, any other questions? We want to make this worthwhile for you guys. I know it's been it's a lot, and sort of jumping between different Globe presentations and trying to manage that can be quite a bit. I know it has been for me. So let us know how we might be able to help you with this. All right, so since I'm not seeing or hearing any questions, does anybody have any plans on inviting their community or having their students use Globe Observer land cover this year? Eric, great question. So if you if you do the biometry protocol, can you integrate that info with the app? Yes, Eric, you can, but you are not going to be the one that's doing it necessarily. You need to do the biometry protocol if you're going to do that muck measurement, where you lay out the tape and you have the hour and you walk and you do that systematic measurement, and you go to the Globe data entry tool and you enter in your data, just like what you've been doing. That'll go into the database, and you'll be able to access it in the same way as the data that you submit through the app. And so it's the database that actually is going to allow us to match your biometry protocol with any of the Globe Observer photos or estimates that are made in that location. And so, I will demonstrate this really quick on the visualization system, because I think that's an important one. Lynn showed us earlier where we can actually go to see that data and how important it is. And when you go there yourself, you need to go in and you need to select biosphere. And then if you select land cover, you have options of the photos or the classification. And if you select photos, for instance, that will bring this up. And I know one of the things, if we zoom in to the Northeast over here, where we've had a lot of historical globe measurements that have been done in the past. We can zoom in and you should be able to just click on any one of those photos or data points. And again, you can bring that up and you should be able to find, in this case, photos, any other measurement data. And so if there were field notes that were included, this is a great place. What type of trees are you seeing? Other pieces like that, that will be added right in here. And so when you download the data for land cover, both Globe Observer data is in the same field in the same location with the same muck codes as those muck measurements that you made and that you entered. So you should be able to find it in the same exact place, under the same exact site, as what you as between the mobile app and those the ground measurements that you made there. And so, it's all going into the Globe site, and that's actually a really good science project, I think, is actually what's the difference between measuring these things versus doing some of these estimates? What's the difference between when you paste something out and you get a tree height versus when you actually measure it out? What's the difference when you measure out that 100-meter pixel and do the muck classification versus standing in the middle of that area and using these photos to do an estimate? That's a really great science question that gets into our methods. What is reliable? How do we become comfortable with the data that's collected? And so Eric, thank you for bringing that one up. It's a great one to think about our protocols and then how our data comes together on the back end. Okay, nice long answer on that one. And so, okay, great. So Andy, you're going to be implementing the land cover protocol this summer for the Aaron. That's great, because what do you need to do to calibrate an aerial image to the ground? Well, you need to reference it. You need to have those ground locations. So I'm excited to hear more about that, Andy. I actually heard about potentially a workshop in Utah later this summer that you might be doing. So
Mescalani.
Exactly, yeah. So tying together land cover to these remote sensing projects, it's the reason why land cover was the second protocol that Globe came up with and developed. It's the foundation. Sites change over time. Let's just kind of keep it going and see how these things have changed over time, and do this rapid assessment if you don't have time to do the full measurements. And that's what I wanted to leave you guys with today. And so I hope I transferred at least a little bit of enthusiasm to you all, and maybe we got over some of the hurdles. Svetlana, I'd like to see you keep doing it, and to hear about some of those problems and challenges, right? Because it's really hard for us to support people if we don't know that you just can't get into the app or you can't get it to work, and so let us know. The Globe Observer team is really willing to help you guys all with whatever you need. So I'm excited about the next year, what we can do. And so take a look at those sites that you've done in the past. How have they changed? And think about land cover in that context of a changing landscape, and how might it be different in 25 years when we're celebrating Globe's 50th anniversary. All right. So if you want to get in contact with us, drop your email into the chat, and we'll make sure to get that, and we'll follow up with you individually here. I've got a lot of interest, as you can tell, passion for land cover, either on the ground or from space, and so I really would be glad to and want to support any students that you might have or communities who are interested in doing this. So it's pretty exciting to be at this stage where 3 years ago we were bringing you a prototype. Now we've been able to collect lots of data, almost 20,000 sites, and we want you guys to continue contributing to this incredible database. So looking forward to all the opportunities this next year. Thanks for joining us today. All right. Glad to see all the excitement. That was my goal.